take you through some of the actual processes that we've worked on. So I'm Karen Wilson, and I have run the Surfaces and Materials Group with Adam for the last 15 years. And we relocated from the UK in January. So the group has an interdisciplinary focus. As Adam's just mentioned, we work a lot with chemical engineers, so spanning a range of different process intensification, from LED photoreactors that will operate in flow to spinning disk reactors, oscillatory baffled reactors for reaction of liquid phase slurry processes, looking a lot at materials design, controlling the porosity and the pore architectures to control diffusion in materials, and also working with engineers looking at the kinetic modelling of those processes to see how we can optimise, again, mass transport through the systems. And also we do a lot of work in the biomass space, working with both chemical engineers but also with bioengineers in the industrial biotechnology space, looking at how we can convert waste material using enzymes into intermediates that we can then take on with catalytic processes to make high-value chemicals and also fuels through adopting the biorefinery process. So our main focus really is to get a fundamental insight on how we can make better catalysts for the processes we're looking at, and a key aspect of our work has really been looking at controlling porosity in materials, so making templated materials with 2D, 3D and hierarchical architectures that allow you to control the diffusion within the pore network, but also looking at the surface chemistry of these to control the absorption of reactants by tuning the polarity and hydrophobicity, and also, if you're working in water, the hydrothermal stability of the materials. So typical types of materials we're working with is metal oxides, either in thin film forms where we'll coat the surfaces of these, and we're looking to expand this through our activities in RMIT through acquisition of an atomic layer deposition unit that will give us a much broader range of materials we can make. Also looking at core shell materials. In this case, these are actually core shell magnetic materials for separation from reactions, but these can also be core shell photocatalysts and a range of different types of nanomaterials. And we've also worked a lot on nanoparticulate metal oxides, mainly in the space of acid and base catalysis. But here we've also spanned a range of other materials, looking at, for example, organically functionalized silicas, which can replace sulfuric acid. You can make the amine analogues of these, but also co-functionalizing them with other organic groups to change the hydrophobicity and polarity. Looking at tuning the hierarchy of zeolites and making bifunctional versions that are doped with metals for some reactions, and also looking at base-derived catalysts from these hydrotalcite or layered double hydroxides, which give you a lot of control over the composition and activity. And also in the sort of bifunctional catalysis space, looking at kegging units or polyoxymetallates, which also allow you to look at strong acids that can couple with homogeneous catalysts for doing tandem reactions. So the types of reactions we've been looking at span a lot recently in the biomass space, so looking at bifunctional processes, taking, for example, sugars through to platform chemicals, or through to fuel additives, and also looking at tandem catalysis for bio-oil upgrading, where you can produce products at lower temperatures by coupling acid and hydrogenation catalysts together to go down a lower energy and more efficient pathway. Do a lot of work with oils and fats, so looking at triglyceride conversion to fuels, but also in that space you can look at making a lot of chemicals and higher value products through looking at ketonization of fatty acids to make lubricants or fuels, and also looking at decarboxylation and hydrogenation to make essentially green diesel, or in this case surfactants if you can hydrogenate it selectively to an alcohol. And as I mentioned earlier on, there's a lot of interest in platform chemicals. So the types of target products we've been looking at are additives for use in polymers, solvents, and also more challenging sort of hydrogenolysis project where you're trying to look at making diols to be a direct drop-in replacement for petroleum-derived products. So obviously in the biomass space you have the option of making a brand new high-performance product or a direct replacement, and we try and look at both sides of the spectrum. So I'll stop there.